What if you're given a probability like 0.9 and asked to find the z-score? You can't guess. You have to work backwards using the z-table. This is one of the most powerful skills in statistics. To find the z-score from a probability, you'll need to follow 3 simple steps. First, find the area of the probability inside the z-table body. If it's not a cumulative area from the left, you'll need to find the corresponding cumulative area from the left. Then you'll need to match to the nearest table entry if the exact value isn't listed. And the row and column intersection gives you the z-score. Remember that z-tables give the area to the left. So always ask yourself, is this a left tail, a right tail, or a middle problem? If it's a left tail problem, meaning the probability that z is less than some given value, the probability is already cumulative from the left in the table, so you can just use it directly. But if it is a right tail problem, meaning the probability that z is greater than some value, you'll need to subtract from 1 to convert to a left tail probability first. And if it's a middle area problem, you'll need to split remaining area into 2 tails and then find the left cumulative. For example, if we want to find a value z such that the probability that z is less than that value is 0.90. So in this case, it's a left tail problem because we have the probability that z is less than some value. And since the probability is 0.9, which is greater than 0.5, we know that that z-score will be positive. So we'll need to look for 0.90 in the table. So if we look in the body of the table, the closest value to 0.9 is 0.8997. And the corresponding z-score would be 1.2, and we'll look at the column to find the second digit, and that will be 8. So z will be equal to 1.28. In other words, about 90% of values are below z equals 1.28. Now, if we want to find z such that the probability that z is greater than that said value equals 0.05. So this would be a right tail problem because we have the probability that z is greater than some value. So the first thing we will need to do, we will need to convert this to a left tail because remember that the table only gives us the cumulative area from the left. So the probability that z is less than some value will be equal to 1 minus 0.05, which will be 0.95. So in this case, we'll need to look through the table for the closest value to 0.9500. We don't exactly have 0.95, but we have 0.9495 and 9505. And right in the middle will be the area of 0.95. So in this case, it will be 1.64, and 1.65 corresponds to the area of 0.9505. So we'll say that z is 1.645, right in the middle of 0.9495 and 9505. In other words, only 5% of values are above z equals 1.645. Now, what if we have a middle problem? In other words, we want to find z such that the probability that negative z is less than z, which is less than positive z, is 0.95. So the middle area is 0.95, meaning that the outside area will be 0.05, because we know that the cumulative area under the curve is 1. So in this case, since the total outside is 5%, and we know that the curve is symmetric, that means that in each tail we will have 2.5%, or 5% divided by 2, which is the same as 0.025. So the left cumulative area will be 1 minus 0.025, which would be 0.975. So we'll need to look for the closest value to 0.975 in the table. So if we look here, we have exactly 0.9750, and that corresponds to a z-score of 1.96. So since our curve is symmetric, we know that the lower bound will be negative 1.96 and positive 1.96 is our upper bound. In other words, 95% of values lie between negative 1.96 and positive 1.96. So here are 3 examples at a glance. We had a left tail problem. We were looking for z such that the probability that z is less than that set value is 0.90. So the left-tailed use was 0.8997, which was the closest to 0.9, and we found the z-score to be 1.28. When we had the right-tail problem, probability that z is greater than some value is 0.05. The left-tail use was 1 minus the 0.05, and we found the z-score to be 1.645. And for a middle area problem, meaning the probability that z is between 2 values, when that probability was 0.95, the left-tailed use was 0.975, and how we found this value, we did 1 minus 0.95, which was 0.05, and we divided that by 2 because the curve is symmetric. We have the same in each tail, and we did 1 minus 0.05 divided by 2, which was 0.975. And that gave us the scores of plus and minus 1.96. So notice the pattern. Every problem ultimately becomes a left-tail lookup. The key is knowing how to convert before you search the table. Normally, you start with the z-score and find the probability. Now, you start with the probability and find the z-score. Same table, opposite direction. Mastering this reverse lookup unlocks a whole new class of statistics problems, from confidence interval to hypothesis testing. Thanks for watching. Please like and subscribe to keep learning with us. And don't forget, math success starts when you stay on the fast track.